This is just one case of the many cases that I bring to each gig. Guitar cables, microphone cables, stereo cables, and I need them all just in case something happens during the gig. If something goes bad, I have to start swapping out cables, and I'm really tired of that. So I made this, the musician's cable tester, and that's what we're going to talk about in this video. Let's take a look at the tester. You notice it has a power switch, either normal or wiggle, and I'll talk about the wiggle mode later. We can select a stereo cable, an XLR cable, or a mono cable. So let's start with a mono cable. The most prevalent mono cable would be a guitar cable or a keyboard cable, something of that nature. Right here I have a patch cord, and let's try that one. Put that in, turn on the power, and do a test. And it says pass. So in about a second, it tests this cable. Okay, let's go to the next one, which would be a stereo cable. And a stereo cable sometimes is used for control signals, like on a keyboard. You might have a pedal that has a stereo cable. So let's plug that in and test, and that passes also. Okay, now let's try an XLR cable. Of course, the most prevalent XLR cable is a microphone cable. Here I have an XLR splitter. I have a male and a female. Actually, I have two females that are connected together, two a male. So let's try this one. Put that in there, and this one in here. And again, let's test, and that passes as well. Now, we can actually test more than this with adapters. For instance, right here, I have an adapter that goes from a mono or a TS connector to an RCA connector. Now, I use RCA connectors in my recording setup, so I want to test that. I have a double cable here. I'll test the reds this time and see. Oh, and it says fail. And the reason it says fail is because I didn't put it on mono, because these are mono cables. Let's try it again. Okay, so that passed. Now you also might have one of these mini connectors. These are usually used on headphones. So let's try these. This plugs in, this plugs in, and again, these are stereo, so I have to go to stereo. And that passed as well. Now, if you got the idea that you can test all kinds of cables as long as they have 3 or less conductors, you're right. All you need is an adapter. Here's a cable. I was about to use this the other day during a gig, and it's a mono, and it fails, and it says tip and sleeve are shorted. And these types of plugs can be a pain in the neck. I'm sure there's a short in here, and I'm going to have to fix it. To see the capabilities of this, I've made a little breakout cable. So you have TRS connectors on each end, and those connections are broken out here. So let's take a look. We have red, which is the tip, blue, which is the ring, and S, which is the shield or ground. So let's test this. Now, if I disconnect the tip, you notice that it fails and it says an open tip. And if I disconnect the ground and we test, it says open tip and sleeve. So this will test all the connections and make sure they are there. Let's also make a short. We're going to between the tip and the ring. And you notice it says short TR between the tip and the ring. So we can check all the different possible opens and shorts on the cables. Now I did mention I was going to talk about the wiggle function. And this comes about from the common experience of you having a cable, doesn't seem to work, you move it, it works, you move it a little more, it doesn't work, so it drives you crazy. So in the wiggle mode, I can put a cable in and it will continually check the cable for 10 seconds while you wiggle it to your heart's content to see if there is a fault there. If after 10 seconds there's no fault, it'll come back and say pass. So let's give this a try. Oh, yes, I already had a short here. So you notice it immediately came back and said there's a short between the tip and the ring because I forgot to take that off before. Let's try it again. And it'll sit there for 10 seconds and wait to see if anything happens. And after 10 seconds, it'll come back and it'll say pass. However, if during that 10 seconds you just happen to slightly have something happen, like that, you get the indication of what went bad. This is really useful when you have those crazy cables that sometimes work and sometimes don't. Now the interesting thing about this is that it's all DIY. The box is DIY, the front panel is DIY, the insides are DIY. So I'm going to show you in the upcoming parts of the video how to build this. I use it now when I go to a gig. I bring this because when I'm at a gig, if something goes wrong, I don't have time to go routing around in my box and just keep on replacing and trying different cables. I use this. So let's get started. The build has two parts. The first part being the front panel and the circuitry that's attached to it, and the second part is the case that the front panel sits in. Here's the front panel, all marked and ready to be drilled. After it's drilled, it looks like this. Here are all the parts that we're going to need to build the circuit. Now I've put the parts on the board temporarily to see how they fit. They fit good. Here's the back of the front panel. Now that I've done that, I've taken the label and printed it out on a regular piece of paper. I've cut it out, glued it to the front panel, and cut out the holes. I've reinstalled the parts, and as you can see, I also put the solderless breadboard on the back, ready to go. This is the wiring diagram we're going to work to. Here's the first part of the wiring. Here's the second part, the third part, and the fourth part, and that completes the wiring. Now we glue the battery onto the back of the panel with hot glue. Now we're going to build the case. We have some 1/4" material that is to different lengths. We have some 1/8" material that we're going to use to make the bezel. We glued the 1/4" material together to form the case, and the 1/8" material to do the bezel. I put the two pieces of bezel together, glued them, and this is what it looks like. The display goes in the back, and this is the front of the bezel. This is the bottom of the case, and you notice it's a little smaller than the case. Here it is glued in, and when you look at the bottom, you see that it forms a nice shadow line around the bottom of the case. Here are 4 posts we're going to glue into the case so we can secure the front panel. There they are glued in, and here is the finished unit before putting on any stain or varnish or paint or whatever you'd like. The instructions for the tester are shown here. The instructions need to be typed into the Arduino IDE, which is a free piece of software you can obtain on the web. They need to then be compiled and then downloaded to the Nano. Now, if all this seems like an awful lot of typing and you don't want to go through that, the description below explains how you can obtain a digital file of these instructions for free. Also, you can get a PDF which contains the label for the front panel and additional instructions. So now you have everything you need to build your own musician's cable tester. Why not get started right now?